We're going to take a look at exploring transformations on section 1-8. Transformations are basically just movements around the graph. We're going to be doing rigid transformations, which is we're not changing the shape of the graph. All we're doing is moving it around the graph. So we're going to take a look at what that happens with a point. So I've got the point A at 4, 3. So 1, 2, 3, 4, 1, 2, 3, 4, 3. It's right there. I'm going to translate this. Okay, a transformation. One of the transformations is translating. So I'm going to translate it to the left 5 units. So 1, 2, 3, 4, 5. Here's the point, 5 units to the left. Then I want to give the coordinates of that. Well, the coordinates of that are -1, 3. And notice that the y value didn't change. Okay, all I did, this was B and this was A. All I did was change the x value because I went from 4, I went left 5, which if I do 4 minus 5, because left means subtracting, if I do 4 minus 5, I get to -1. So I could have done this without a graph, just knowing what it means to go left 5. Left goes on the x's, okay, and right goes on the x's, up goes on the y's, down goes on the y's, up in the positive direction and down in the negative direction. So I did part 1. You should do part 2 as part of your notes, and then double check it. Number 3, transform y equals f of x by translating it 2 units to the right. Label the new function g, compare the points that make up the two functions. Which coordinate changes x or y? And so we're taking this graph that's on the right, and we're going to translate it 2 units to the right. So I need a few points in here. Well, I'm going to take this one. This is the vertex. This is -2, comma 0. And then I can really take any other points that I want to, but I want to make sure that they are meeting at these crosshairs here, like this. Okay, they meet at the crosshairs. And I just want to make sure that I take that point. So I've got -4, comma 2. I'm going to take some from the right as well. Let's take this one. That's 0, comma 2. And there's a spot for one more, so we might as well take one more. Over here at 2, comma 4. So I'm going to translate that 2 units to the right. So I'm going to take each one of these points and I'm going to move them 2 units to the right. This one's going to go right to, this one's going to go right to, the one over here that was at the crosshairs is going to go right to, and I end up with this graph that looks the same as the other one, except that I just moved it to the right. And then I'm going to take some points that make up this function, and so I've got 0, comma 0. So this one was old here. I had old y's and x's. Let me make a new chart here. I've got on my new one I've got 0, comma 0. I had -2, comma 2. I had 2, comma 2. And 4, comma 4. So I want to compare these and I want to look at them and I want to see which coordinate changed, the x or the y. Well, the x's look like they stayed the same. I've got -2, -4, 0, and 2. Okay, and I've got all those same numbers, but they're in a different order. Okay, and so that's the one that changed. The one that stayed the same was the y's. It still goes 0, 2, 2, 4. Okay, those didn't change. And so the ones that changed were my x's, and we knew that because I'm moving this to the right, okay, and so the y's aren't changing. It's not going up or down at all. It's just going to the right. Okay, so it's going to move along the x. The x is going to change. Each x value added 2 to it. So I took -2 plus 2 gave me 0. -4 plus 2 gave me -2. 0 plus 2 gave me 2. 2 plus 2 gave me 4. Okay, so it follows along the way that works. Number 4, transform y equals f of x by reflecting it across the x-axis. Label the new function h. Which coordinate changes x or y? Well, let's do the same thing that we did on the last one and make this an old x and y, and then we'll make a new one over here. On the old function, let's just find a few points here. I've got the same graph, so I've got that -4, 2, -2, 0, and then I've got 0, 2 here. There's a space underneath for one more, so let's do that one more, 2, 4. I'm reflecting this across the x-axis. Well, reflecting means that I'm going from the top above the x-axis to below the x-axis. It's going to reflect itself. And it's going to be exactly the same number of points. So this one here is 2 points from the x-axis. So if I start at the x-axis, I go up 2. And so I reflect it across, I'm going to end up going down 2. This one's on the x-axis, so if I reflect it on the x-axis, I'm going no units away from x. And so when I reflect it, I'm going no units away from x. On this next one, I'm 2 units up, so reflected, it's going to be 2 units down. On the next one, I'm 1, 2, 3, 4 units up, so I'm going to be 1, 2, 3, 4 units down. Okay, and so then this graph reflected on the x-axis looks something like that. Okay, it's the same exact graph, just flipped upside down. And so let's take those new points. I've got -4, -2. I've got -2, 0. I have 0, -2. And I've got 2, -4. Well, when I look at those, again, the question is which coordinate changed. Label this h, so this is h. Label the new function h, which coordinates change, the x or the y? Well, the x is -4, -2, 0, 2, -4, -2, 0, 2. The x's did not change. The y's changed. And that should make sense. I flipped it upside down. When I flip it upside down, I didn't move it left or right. I just changed where the y values are. Okay, and so this is the one that changed in comparison. And notice how it changed. When I reflected it, the way that it changed was that it just ended up having the same numbers, but with a negative in front. And that's an important thing for you to understand, that reflecting just causes you to have that opposite sign in front. Okay, opposite sign in front of each one of these y values. So let's take another one here. Yeah, let's do this one on number 5. Y equals k of x by translating it down 3 units. Label the new function p. What happens to the y coordinate in each new ordered pair? Okay, so we'll actually keep this in. If you didn't like making a new table, a new and old table, let's try to see what happens here in this one. So I'm looking at just what happens to the y coordinate, but I'm going to translate each one of these points 3 units down. So this point is going to go down 3, 1, 2, 3. This point is going to go down 3, 1, 2, 3. This point is going to go down 3, 1, 2, 3. Let's see if we can find another point here. Maybe this one goes down 3, 1, 2, 3. And so now my new graph has an arrow at the end here. Goes up, comes down, goes up. Looks exactly the same. I just moved it down 3. So I'm going to label that new function p. Done. What happens to the y coordinate in each new ordered pair? Okay, so again, let's look at the ordered pairs. The first black graph is -4, 0. Then I've got -2, 2. Then I have -1, -1. And 2, 1. Well, what happened to the x values, or the y values? I've got -4, -3. So in comparison, I had -4, 0, and now I'm at -4, -3. So what I did was I took the y and I subtracted 3. I went down 3. Okay, so I took the y value and I went down 3. This is just another way to write this table if you needed to have an ordered pair table for this. Okay, so this was the old one. This is the new one. I went down 3. This x value is old and new because the x value didn't change. Okay, and so if I wanted to write it in a separate ordered pair, the x value, the x column would not change if I wrote it in a separate table. So I've got -4 comma -3. -2, I subtracted 3 from that, so that gives me -5, and let's check that. -2, I had 2 when I subtracted 3, so that gets me to -1. So I should be at 2 comma -1, and sure enough, there's that point. So same thing with these y's. I've got -1 minus 3. That should get me to -4. -1 comma -4. Sure enough, that matches up. And then the last one, I'm at 1 and I'm subtracting 3. That should get me to -2. 2 comma -2 is where we're at right there. Okay, so all those points match up. Again, you could have made a new x and y here and done this problem the same way that we did the other two. Again, it doesn't matter either way which one you're going to do. To describe how the coordinates of a function change when it's translated 2 units to the left and 4 units up. Well, the coordinates, I have x comma y, turns into, to the x's, I'm going to translate it 2 units to the left. Well, to the left is subtracting 2, and the y's, I'm going to move it 4 units up. So up means I'm going to add 4 to it. Okay, so that's what happens. Describe how that happens. I'm going to subtract 2 from the x's, add 4 to the y's. So again, all in one column here. I've got the original with these points that are already given to you. I'm going to translate them left 1 unit. So I'm going to take x and subtract 1. That's left 1. I take the y's and I'm going to go down 5. So I'm going to go down 5, which is subtracting 5. And so I just have to do this in parts. This is what translation does. It takes the ordered pairs and just moves all of them. So I've got -3 minus 1 is -4, -1 minus 1 is -2, 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2. Then I'm taking the y's and I'm subtracting 5. So 3 minus 5 is -2, 1 minus 5 is -4, 2 minus 5 is -3, 1 minus 5 still is -4, and 2 minus 5 still is -3. Okay, so if I'm looking here in terms of old and new, this is old in here. And this is new out here. Okay, so my new points are at -4 comma -2, -4, -2. New point is -2 comma -4. New point is 0 comma -3. New point is 1 comma -4. And 2 comma -3. Okay, so you can see that this graph is going to look exactly the same. So it's going to go down here, come up here, go down here, come up here. And the graph looks the same. I just moved everything to the left 1 and down 5. And that's a translation. Okay, it's a rigid transformation. And so when we look at those two words, transformation is a change. Translation is moving it left and right, or up and down. So what you're going to do is you're going to take a look at this worksheet. And I've already got the information plugged in for you for what I want you to do. You're going to use a table to help perform the operation. So you're going to take the graph that you have, pick the ordered pairs. And so this one is similar to one that we already did. Pick the ordered pairs. So this is 0 comma -1. And then I'm going to take, and if you want to, you could change this to new over here, instead of putting it in one ordered pair or one table. But if you can do the one table, then this becomes old and this becomes new. And x's is both old and new because I'm not changing the x's. The x's are staying the same. The y's are the thing that's changing. So I go through and I change the y's by subtracting 2. So this should be -3. If you're doing new ordered pair over here, it should look like this. So either do the one on the left or the one on the right. I don't care which way you do this problem, but you need to get used to the idea of transformations. We're taking and we're translating things at this point left and right and up and down. So when you look at the second sheet here, we're going left and up. So we're doing two things to it, reflecting across the y-axis, reflecting across the x-axis. Okay, so take a few minutes. I will put the key up, but you should try to go through these, do as many as you can, and then check the answers after you're done with them.